So thanks everyone for joining us. I am Jim Varney. I'm CEO of Product Insight, a product development firm just outside of Boston, Massachusetts. And we're here to talk today about the dirty little secret in healthcare and biotech and med device, which is the amount of waste and the carbon footprint that's created by all the stuff that really is used by the devices and used by the instruments. For an industry that obviously does an amazing amount of good in the world to cure diseases, to help people become healthy, to do research that's important for our future. There is a growing interest and a growing awareness of the amount of waste and actually the footprint that's caused by this industry. There are several things that can be done to help mitigate these impacts, and to help talk about those things today, I'm joined by my guest, Andy Marshall, who is the CEO of Sterilis Solutions. Say hi there, Andy.
Jim, thanks for having me. Nice to be here with you this morning.
Great. So to kick things off, I think in this topic, there's often confusion about, what kind of waste are we really talking about? What is biohazardous? What's just regular waste? What's medical waste? There's a lot of terms here, and it can be confusing even for people in the industry like myself. So, Andy, I think if you could start us off by just a brief description of, what is meant by medical waste as compared to biohazardous waste.
Yeah, absolutely, Jim. Thanks. Happy to dive into that just a little bit and give everybody a little bit of a better feel for some of the distinctions that are made between waste and medical waste and biohazardous waste and so forth. When you really look at regulated medical waste as a whole, it's going to be broken down into several different areas. On the biohazardous end of the scale, you're going to have things that like sharps containers, red sharps containers specifically, as well as red biohazardous waste bags. As you move a little bit further down the list of other categories of medical waste, you're also going to find things like pharmaceutical waste, things like trace chemo, or even pathological waste, whether it's amputated limbs or organs and so forth. The areas that, of course, we're most familiar with are going to be that are the most common, which represent, depending on the venue, whether it be in a laboratory or whether it be in a hospital, it could represent anywhere between 90 to 100% of their regulated medical waste. That being red sharps and red bag waste.
Wow. Yeah. So and the scale of the problem here is pretty massive, right? I mean, the amount of waste that's generated at hospitals, laboratories, and whatnot. And could you also talk a little bit about that's not just like the amount of, say, waste that's going into landfills, but there's a carbon footprint that's associated with this, correct?
There is, and so there are several different sightings out there, and of course, Google can be a tremendous resource, but hospitals and labs, if we were just to isolate it down to those two in particular, they're responsible for emitting just under 5% of the world's greenhouse gas emissions. In fact, Johns Hopkins put out some information just roughly about a year ago, and to kind of put a finer point onto that, around 80% of the healthcare industry's carbon footprint, just narrowing it down, 80% of the healthcare industry's carbon footprint is a result of the production, transportation, use, and disposal of the single-use plastics that are commonly found within healthcare and life sciences applications.
Wow. Yeah, it's a tremendous issue for sure, and it's something that is shared across the industry in terms of, on our side, our clients, right, are device makers usually, people who are creating equipment for laboratories, hospitals, these sorts of things. But they're the folks that are actually creating the core technology and the devices, the instruments that are actually servicing folks. And your company, your customers are the end users really of these devices. So it's the full spectrum, right? So if you want to just take a couple minutes and describe what does Sterilis Solutions do? Like what are you focused on?
Yeah, absolutely. I think before we walk into Sterilis Solutions and what we're doing to be able to help address in a more sustainable fashion, it may be helpful to kind of give a sense of what existed prior to Sterilis Solutions and what largely still exists today through medical waste treatment options. And generally, or historically, regulated medical waste is bound for one place, and it's landfill. Now, how it gets there can be a little bit different. If you look at the industry where there are regulated medical waste hauling companies, they have a couple of different treatment methods that they use. For example, an offsite large format autoclave that's utilizing a tremendous amount of power, tremendous amount of water, where they treat it before then discarding it into a landfill. Another treatment option that is used less and less today in the interest of reduction in the carbon footprint itself is incineration, to where the waste is simply burned, converted into ash, and then ultimately winds back up in a landfill. A third option, which is less prominent in the U.S., it's utilized very sparingly, I would say, but it is used almost everywhere in the European countries, is a waste to energy platform where that waste does get burned, but is ultimately a small portion of it is converted back into power that can be placed back onto the grid for and again in a nominal amount. Relative to Sterilis Solutions, we're coming at it from an entirely different angle, as opposed to having trucks and with emissions and incineration and landfill and so forth. We manufacture and sell a product that takes the regulated medical waste, specifically the biohazardous waste, red bag and sharps waste. We utilize pressurized saturated steam to first sterilize the waste. That's then ground down into a shredded sterile confetti. And through that process, the waste volume itself has been reduced by roughly 80%. Now, one of the things that we're super excited about that we've been able to realize over the past couple of years is to be able to find alternatives for the waste post processing through our product, the remediator, that does not include landfill, incineration, or waste to energy.
Great. Yeah, and that touches on the spectrum, right, of solutions that we have as a whole industry. The folks of us like us that are involved in the industry, and certainly one of them is on the back end. How do you deal with this? But I think, and the interesting thing from my point of view is that designers and engineers and folks like myself that are either working within device manufacturers or who are in the consulting industry also share a burden in how we actually help to develop the instruments and the consumables themselves to feed into that system towards the end to make it actually work out better. And one of the we've seen over the last couple of years, for instance, a real shift in the industry in terms of an awareness from the folks we work with, whether it's established companies that have been in the market for years, or we work with a lot of startups, right, who have some really exciting new technologies, and they're trying to get out into the market, and they're mostly concerned about, for instance, market adoption, right? They want to get their product out there, and they're obviously concerned about FDA compliance, regulatory. They need to make sure, obviously, that their instrument is safe and reliable and effective, and all of those things. Typically, the consumable in the past has sort of fallen by the wayside, right? Of like, well, it's not super important, just make sure that the product itself works really well. But really, from our point of view, we see, and also from the folks we're working with now, that paying attention to this is really actually important, not just from an environmental standpoint, or even a regulatory standpoint, but it's a business decision. And so we're often asked, like, well, why should device makers care, right, about this issue? Like, why should I really devote energy and money even to designing these consumables? And when we talk about consumables, we're talking about things like, anything that's holding reagents or samples, whether it's plates or cartridges or tubes, or it could be blood, it could be chemicals, it could be chemistry, it could be any type of thing like that. But it's generally, as you mentioned, it's the single use stuff. You've got, and this is basically the way that the industry is built around. The business model is, the razor and razor blade
Right.
type of method, right? Where device makers are they build an equipment, a device that is, they maybe don't sell that many of them, right? They maybe are in low hundreds, or thousands, things like that. Um, and they sell those to their end, buyer, who is actually your customer, in a way, the facilities, right, that actually buy this equipment.
Right.
But really, where the business makes its money is from the consumables. They have proprietary technology that's built into them, whether it's chemistry or whatnot. But it's by selling those consumables to the facilities, is the revenue stream. And it's important, obviously, these businesses have to work, right? And they have
Sure.
to make money. And it's often a very important part of their business model. Yet what we're seeing an increased awareness of is how the consumable itself and how that's designed with the device, how that impacts their business model. And it has to do with market adoption. We have
Mhm.
several different stories. Like, one quick anecdote is, we worked with a startup company that had some really amazing technology, and they were really focused on the traditional, things that people will be concerned about in terms of the patient, what the device is being used on, the people who are using the device, like whether it's doctors, nurses, lab techs, that folks, and really focusing on those people as the primary users, but almost a little bit ignoring a big user of this, which is the facility itself, right? And so when they went to try to get out into the market, they got a lot of pushback from their end customers because of the size and complexity and cost of the consumable that was required, right? And in the end, a lot of their customers just decided to, keep using old technology instead of this really great new technology, just because of the additional cost that they were going to have to bear from a facility
Mhm.
standpoint, because they have to pay for everything twice, right? They
Right.
have to buy the consumable once, and then they have to pay for it again on the back end of disposal. So we see much more now where customers or clients that we're working with us, even startup companies, they're investors, they're folks that are on their guidance committees and everything. They understand that this is a high priority for them. They need to minimize, to optimize, really, the consumables to just the bare minimum, so that it reduces their cost, for one, and it reduces the end customer's costs, and yet still allows for them to obviously have a revenue stream, and to be functional. So it really has everything to do with market adoption and business sustainability, as well as, obviously, environmental sustainability and social sustainability. So with that being said, you know, we obviously are seeing pressures that are on our customers, right? The device makers. Um, what kinds of pressures are the facility managers under for this kind of issue?
Yeah, absolutely. So a number of things. They're looking, obviously, there are a number of our customers who have zero landfill initiatives by 2028 or 2030 or whatever year that they've committed themselves to, and they're looking for uh, alternatives to what's historically been the norm for the last 40 some odd years. One of the things to maybe mention or tag on to what you just mentioned earlier, Jim, is the fact that we're seeing the manufacturers that we both work with uh, take a greater interest in what the consumables themselves are being made out of, understanding that I guess really in support of their customers' initiatives for zero landfill use. So they're recognizing that there are certain plastics, certain polymers that are better from a recyclability perspective than others, and that others have very limited options that could be that they could be utilized for in a post-use scenario. But relative to the kinds of challenges that our customers are facing. They're definitely looking to bolster and further support their sustainability goals and objectives, whether that be reducing carbon footprint or energy consumption throughout the process, human health, ecotoxicity. There's a lot of different initiatives out there, but none ranking quite as high as offsetting or reducing greenhouse gas emissions and so forth from their business units.
Is there a lot of regulatory compliance that's either in place now or coming down the road?
Well, from a regulated medical waste perspective, there absolutely is a significant amount of regulatory compliance that is required, really. And, from a federal level, it's overseen by EPA and OSHA, but each individual state may or does have further requirements or enhancements that must be met to meet those regulatory standards. So, for example, the length of time that they must keep track of all of the supporting manifest documentation, or the required steam sterilization times or biological kill margins, so forth and so on. So those regulations have been in place and for many, many years. Very seldom are they updated or modified to reflect any sort of meaningful change. Some states, for example, require a pretty involved, pretty heavy surveillance period when changing their protocols relative to regulated medical waste, maybe over the first 6 to 8 weeks, and so forth, if they're looking to deploy an alternative to what they've been doing for the last 30, 40 years.
Right. Yeah, that's something that's often very surprising, even to folks in the industry, is across state to state how different the laws, regulations, what's allowed, what's not, are. That it's almost it is almost by a state basis. At least in the United States, there are some overarching regulations, but in a lot of cases, they've left it down to the states in terms of any requirements of how you actually deal with regulated medical waste.
Right.
And it can be very confusing. If you're a device maker who plans on marketing in North America and also potentially in Europe, those can be very, very different environments to design a device for. Are you aware of, is there anything that is very specific to this in terms of reducing, say, carbon footprint or waste in Europe that could potentially find its way over to the US at some point?
Absolutely, and we're starting to see the beginnings of that now, just in a handful of states here in the U.S. And it's what's known as extended producer responsibility, to where the onus is really put back on the manufacturer of that product to see to it that safe and practical disposal happens relative to the products that they actually manufacture. So I suspect within the next 3 to 5 years, that's going to become more prominent here in the U.S. You'll see some of it now relative to the packaging that the products are actually coming in. So we're just on the seeing the break of those initial waves here in the U.S., which is very, very common in many European countries. It certainly has an impact on their tax rate and so forth for the manufacturers of these products, should they not be in compliance with that extended producer responsibility component.
Yeah, and it makes a lot of sense because, certainly there are a lot of other regulatory requirements that, say, have been, not implemented necessarily in the US, and things like RoHS, like material compliance, things like that, that device makers have been following for years, because if you want your device to be able to be sold in other countries, then even if it's not a regulation in the United States, you need to pay attention to it.
Absolutely.
And this is another example of that for sure.
Absolutely.
And we're looking at the devices or the burdens that are placed on the end facilities, right, in terms of having to deal with all of these things, and also the device makers of we have to maintain safety, right? We obviously, that's the key component with
of course,
regulated medical waste is, is safety for the environment, safety for others, safety for people who are using the device. Obviously that can't be compromised, but there are a lot of things that could be done, a lot of best practices that could be implemented to help reduce or reduce impacts, but also to fit into kind of the new idea of, like you were saying, it's not just the old way of dealing with waste, right? We have new options that can allow for sortation or recyclability, things like that. And so I just want to highlight, from our standpoint, from the design and engineering standpoint, a few best practices that we try to follow every time we're designing anything. And first off was, obviously risk, and safety is a big issue, but wherever there's low risk, to look at options for reuse. And it's often sometimes very compelling from a device manufacturer standpoint to basically take everything that is even remotely close to any kind of consumable or waste product or sample or anything, and just basically almost wrap a giant bag around it and say, well, just throw all of it away. It's easier to sort of think about it that way, certainly, and because it's, you take everything that could potentially maybe be hazardous or next to hazardous, and you sort of like just make a bubble around it and get rid of it. But again, as we're seeing more of, that puts a big burden on the end user, which is the facility, right? And so there are lots of options usually within looking at the system itself to basically winnow down the amount that really needs to be thrown away, and to shift some of that, anything that's really very low risk or no risk type of components, to make those something that's built into more of the rigid componentry of the equipment. Things like maybe it's liquid reservoirs, things like that, where it doesn't have to be something that's thrown away every time. It could be something that is cleaned and sterilized in another fashion, right? We are seeing a little bit more of that come back, where there is more acceptance in the market now for going through the steps of, say, sterilization and cleaning, instead of having to throw everything away. So certainly looking at the whole process and really saying, okay, well, this is really everything we have to contain. Let's focus just on that. And the second part, it would be minimizing the structure of the consumable itself. This, sounds kind of obvious, but certainly it cannot be obvious sometimes when you're going through the process. Anything that is load bearing should really be built into the equipment, the device itself. And we've seen many examples where, say, a cartridge that might be loaded into a device, maybe there are valves or actuators or something like that because of the process, you have to, say, push on something or open something, all part of the technology. But you have to, if you think through it from the beginning and make sure that all of those forces are basically supported by the equipment itself, and not have to be supported by adding more plastic or more walls or more structure to the actual thing you throw away, that'll go a long way to reducing the material that's used, reducing the cost to make that part, and reduce the burden on the back end and the footprint. And again, it sounds obvious, but the problem with that is that it does require it requires device makers and engineers and designers to think about this at the very beginning, right? Because you have to really think about the system design to make sure that that's supported from the beginning. It can't be something you add on at the end.
That's right.
It's really important to think through from the very beginning.
Be done very much ready, aim, fire, as opposed to ready, fire, aim.
I know it's something that people have known for a long time, but still is very hard for us to kind of wrap our heads around when you're in the thick of it. All right, and the third thing that designers can do is to help separate hazardous waste from regular waste. Now, there was a study that was done by Mass General Hospital here in Boston just a couple of years ago in 2020. And they looked at all the waste that was kind of coming out of their ER, and they found that upwards of 85% of the red bag waste, so the regulated medical waste, up to 85% of the material in those bags actually doesn't really qualify as regulated medical waste. It could have gone through other waste streams. Now, granted, this is an ER, so folks are working fast and furious at saving lives, and they don't have time to really try to have to think too hard about what goes where. But it does bring up, I think, a problem where a lot of the folks in healthcare, they don't have the bandwidth often to have to do a lot of work to separate things, right? To make a lot of choices. If the
Right.
products themselves, if the consumables themselves can be designed in such a way so that that choice becomes very, very obvious, right? It's built into the design of the disposables themselves, or into the device, or other things like that, to allow that sortation to happen immediately and without really deliberation. That can help reduce the amount of waste that's going into the waste stream to begin with, right? So
That's
it's
exactly right.
it's a design. It has to be thought of from the beginning as a design decision, right? But that said, we know you can't eliminate all of those issues, but if it can help to cut that number down, to something that's more palatable from 85%, that can go a long way, certainly, to helping out the issue.
Absolutely.
Um, and the fourth thing that the designers and engineers and the device makers can do is to, when they're designing their disposables or their consumables, to avoid mixing materials, right? And this is something I know that is very much close to your heart as well, Andy. That if the materials themselves are going in, that we're keeping things to, say, single stream materials as best we can, right? To
Right.
a certain kind of plastic, or all glass here, or instead of mixing glass and metals and plastics and different kinds of plastics all in the same consumable, that becomes harder then to separate out at the back end, right? If you want to try to take out some of those materials for recycling, and only have to incinerate, or go to landfill for the things that are really important to do that. Um, and and it does bring to mind, though, as obviously these are things that can be done on the design side. They're super, super important. They tie into what's happening on the back end, on the
Right.
facility side, right? Like how they then deal with their waste. Ideally, the design uh, stages can kind of feed into those what the facilities want to do on the back end, and actually make that happen easier, right? Like, if we can make that job easier, then that'll go a long way to then them putting other better alternatives in place to what they currently do now. And kind of to that point, then, how is it that Sterilis Solutions then can kind of work with those design innovations, right? And help as a better alternative, say, for facilities. How can that kind of help them to reduce their waste issues, as well as just the kind of the solve some of the bigger problems that they have with some of the traditional ways of dealing with waste?
Yeah, it's an interesting point. From a manufacturer's perspective, I think, certainly education is in order relative to the different types of opportunities that could or may be available for those single-use plastics, so that they don't have to reach a landfill. So if there are opportunities to make things out of a better regarded plastic like polypropylene as opposed to PVC or silicone, then perhaps that would enlighten them, and kind of help inform and guide their design of future products or single-use plastics. Because what's happening on the back end for these high quality polymers is those are now able to be taken, and through process of it can be labeled differently, advanced recycling or chemical recycling, or to where in one of those areas, you can actually gasify the plastics and basically convert it back into virgin-like material that goes back into supply chain, to be able to now introduce a completely circular opportunity back to the customer, as so many of them have really, again, as I think I mentioned earlier, have adopted zero landfill initiatives, or some really noble and robust sustainability objectives that they're looking to meet. And that really all begins with proper design and evaluation, everything from the hardware, but also the consumables themselves, to ensure that as much value as possible is extracted post-use, commercial, post-use industrial, for those kinds of plastics, to avoid landfill.
That's great. Are there other ways too that I think you had mentioned things like tracking waste and things like that. Are there issues? Are there ways in which also um, you know that facilities can benefit from alternate technologies, right, to for their own quality control or trackability, things like that?
Sure, absolutely. So with relative to Sterilis Solutions, again, we're kind of going against the grain as it relates to third-party regulated medical waste hauling. We come at it from a different angle altogether in the sense that we actually manufacture and sell a product that lives on site. Their waste is steam sterilized and ground down or shredded down into a confetti-like material, reducing the volume by about 80% of what it was going into our machine. Through that process, and what the customers currently experience today is writing basically every component of waste down on a manifest and being able to track that, and then they've got to retain that information for in some cases up to 5 years, so for regulatory and compliance purposes. Relative to our product, beyond steam sterilizing and shredding their waste, it's really an Internet of Things product where it's capturing and storing the parametric data from each run cycle. So what that means is that instead of the end user of our product, instead of them having to continue to write that information down on manifest documentation and retain that for an extended period of time, our product really does all of that for them, and it retains that information for them in the cloud that they can pull down 24/7, 365, that's going to contain valuable insights and information that they may be tracking just outside of the manifested information to report things like the weight of the volume and the type, whether it's sharps containers or whether it's red biohazard waste, along with date and time stamping, capturing the end users, who are the power users, for example, but also simplifying and streamlining the reporting process as opposed to going back and digging through their archives of scanned document after scanned document to be able to recall the exact same information. So we really, if the technology to our product is really the backbone. It's kind of the super highway. It also allows us to be able to remote access into those machines to get ahead of any potential troubles that may lie ahead relative to a certain waste load or something that is being processed. So lots of value in the technology, but certainly the manifest and the tracking or traceability of that waste is of utmost importance. We're also really excited to be able to introduce very soon the opportunity to be able for our customers to be able to understand what the reduction in their carbon footprint looks like utilizing our product versus utilizing the way that they are likely doing now with third-party medical waste hauling.
That's really important too, because I know that a big part of green initiatives and targets, right, is you have to have visibility into what are we actually doing? How do we actually measure the reduction that we're doing, and not just kind of throwing it out there in the world. I know in one of the big issues with a lot of the current ways that things are disposed of is it's often you might have somebody who's picking up the waste at a facility, but then that gets transferred someplace else, and then it gets with another third party, right? You once it gets out there, it kind of goes into the ether, right? And it's really hard to know, is it really going where I think it is? Whereas having an on-site facility or an on-site device like yours, it helps facilities to really better manage that. So that's fantastic.
It does.
Great. So this has been a really, really fun conversation. I've really enjoyed chatting with you, Andy. It's always great chatting with you every time I do. And I thank you so much for being a part of this talk today. I know, I've learned a lot. I hope that our listeners have learned a little bit as well. I invite them to check out Sterilis Solutions website as well as Product Insights website to learn a little bit more about our businesses. And yeah, I look forward to continuing conversations as we go forward. So thank you so much. Appreciate it.
Jim, thanks for having me. It was a real pleasure. I appreciate it.
All right. Thank you. Take care.
Bye-bye.